about how we describe position and time. Time is generally measured in seconds when it comes to physics, and it's your dependent variable when graphing. If we look at position, we have to recognize that first, it's the dependent on time and the dependent variable, and second, direction totally matters. Ever stop to ask someone directions and they say, oh, it's about 8 blocks from here. Perfect! I know the distance, but I have no idea in which direction. Not very helpful. When the direction is left out, it's called a scalar quantity. Distance is a scalar quantity, and it's represented by a lowercase d. Position needs a direction relative to something. My grandma still gives directions like, turn right at the red barn and go half a mile. The red barn is the key to everything. When you have a distance and a direction together, we call that a vector. No, I don't mean the tiny toilet guy. You can tell a vector by the arrow on the top of it, just like this. The direction is given as either a compass direction, north, south, east, west, or a positive or a negative. This diagram should help. You can also find it in your textbook. Uniform motion is probably the best point to start examining the relationship between time and position of a moving object. Uniform means the object is traveling at the same speed, another scalar quantity. If we add in direction, we are in business, and we have a vector. So remember that arrow? Direction. We examine this motion by looking at position relative to time. That means in order to discover the distance traveled over a given period of time, you need to be able to calculate intervals. This is done by taking the final time, or TF, and subtracting the starting or initial time, TI. Looks like this. The time interval is the change in time and is represented by delta t. Not only do you need to be able to calculate the time interval, but you need to be able to calculate displacement, or position change. Remember, position is different from distance because it has that direction attached to it. So the change in position is calculated by taking the final position, df, and subtracting the initial or starting position, di. That change, like relative to the red barn, looks like delta d. We'll try this out.